Welcome to our podcast, Health Discourse with Sakshi and Sushant. Keep listening to us. We are available on Spotify, Apple Podcasts, and Amazon Music. Good morning, everyone. Welcome to yet another episode of Health Discourse with Sakshi and Sushant. So, hi, Sushant. Good morning.
Morning.
So, folks, today we will be talking about something which is really becoming trending in terms of health. As we can see that these days, a lot of people are concerned about longevity and aging. And with this, we can also see a lot of supplements and other therapies. They are actually coming into prominence because of that. So, Sushant, let us decode the concept of longevity first and let our listeners know how aging actually occurs. Over to you,
Okay.
Sushant.
Okay, so this has become a hot topic, as you rightly pointed out, since COVID, and people are not concerned about their health. They want to live longer, they want to have a healthy life, and blah blah blah, right? But again, longevity or healthy aging is very poorly understood, right? And people generally restrict its understanding to either DNA methylation or certain genes, and they start blaming their genes, right? So this is all bogus things to blame your genes, or probably focus only on DNA methylation. And again, I'm going to talk about each of these things today, right? So first thing is aging is linked to your health of your cells, right? So the ability of your cells to be healthy, to replicate, to produce more cells, right? So that's how the basic cellular health comes into picture, and there are multiple factors here, right? When we talk of cellular health, so when our cells are not able to do this job, what we call is cellular senescence, right? Which is again is linked to aging, right? And again, we can't blame DNA or our genes for it, and there are multiple factors. Again, in terms of your cellular health, your mitochondria plays a key role, right? Uh, and earlier, a lot of people used to blame it for telomere, and again, telomere shortening, right? And telomere, what telomere is? Let me tell you. So we have chromosomes, right? The telomere are the protein structures at the end, both end of chromosomes, right?
Right.
So there's an enzyme called telomerase, right? That keeps the telomere from wear and tear, right? And as so our endothelial cells, the cells lining our blood vessels, they have very limited cell division. As they divide with the passage of age, more cell division take place. Uh, we don't have enough of telomerase, and then there is that leads to telomere shortening, which is again linked to cellular senescence, right?
Okay.
So, so essentially, the shortening of length of telomere has been earlier linked to, aging, but it is now busted. It is because people would have telomere length may not shorten, but still they would age, right? So there are multiple factors at play. Again, you know, even a telomere length, right? Here is important aspect that nitric oxide production, right? Again, we have discussed about nitric oxide day before also, that nitric oxide plays a key role in upregulating telomerase activity and inhibiting the telomere shortening,
Right.
right? So,
Mm.
so having sufficient nitric oxide production is the key to uh, to actually have a healthy aging and longevity, right?
Right.
So that is one of the aspect we should know. Again, nitric oxide we know is used in oxygen uptake and delivery, is used, facilitates insulin signaling, regulating your blood pressure. It's a vasodilator, right? It plays a key role in cellular signaling as well. That is how cells communicate, right? So so there are multiple benefits nitric oxide has, right? Second thing is, people talk of DNA methylation, and I've heard some company recently launched their biological age, and uh, based on DNA methylation. Again, DNA methylation is just one tiny part of the story.
So that's like a test that you're saying. It's like a
Yeah,
test.
so let me tell what happens is, so again, we all know that genes expressed one per genes expressed in our body, most of them are microbial. So 99% genes are microbial, only 1% human. So when we talk of DNA, human DNA methylation, you're focusing on 1% of methylation. So methylation in genes means epigenome, right? So again, it means some genes are underexpressed or not expressed,
That's
right?
correct.
Right? So that is what methylation is. It is only a one part of the story, and it only focuses on the human genes, right? So there are multiple other factors which comes into picture when we talk of biological age and aging, right? Again, there are biological marker which would look to younger or old, right? And again, there are a lot of inflammatory markers, right? So it's not only about the DNA methylation, it's also about how your oral microbial genes are expressed, how your mitochondrial genes are expressed, how your gut microbiome genes are expressed, right? So there are multiple factors, probably, your inflammatory markers such as, methane gas, ammonia, LPS, we have discussed all these are metabolized released by your microbiome, oral H2S production, oral methyl captain conversion, halitosis, so bad breath also plays a role, right? Um Bitrate, vitamin B12, a lot of these, so we have to look at various metabolites, right? Like oral pethopoints, which could impact your nitric oxide production because one of the pathways nitrate to oral microbiome for nitric oxide production, right? So there could be methane gas or production of methane gas or production of ammonia, low bitrate, low absorption of vitamin B12, right? Even your neurotransmitter production like GABA, right? Stress response, so all these have an impact on your aging cycle, right? Uh, so again, it is not only about DNA methylation or telomere length, right? There are multiple factors. Again, even high homocysteine levels, which is again a conversion of uh, sulfur containing amino acids, right, which gets converted into homocysteine. Again, high homocysteine is linked to cellular senescence, right? And even there are certain research which have found that uh, periodontal disease, it has an inverse relationship with telomere shortening, right? So if there you
That's
have
a
periodontal,
shocking revelation, I must tell you, because many people take their dental or oral health issues for granted, right? That is
yeah,
a very, very surprising relationship that you're establishing here. Please go on.
yeah. So again, people who have periodontal disease, again, when we have an inflammation in the mouth, there is low nitric oxide production, right, which could directly impact your gum disease. And again, the high incidence of gum disease like periodontal disease, there is more of telomere shortening, right? That's another biomarker. But the most important thing is mitochondria. Again, what mitochondria is, it's an energy powerhouse. We generally think it is an ATP cycle. It gives us energy to do a lot of activities, daily activities, right? It feels energy for our cells to perform various actions, right?
Right.
Again, we know ATP is adenosine triphosphate, right? When we do something, when we need, there's some inflammation, there's some stress going on, or there is, a lot of nutrient deficiency. So we generally we use ATP, it gets turned into ATP, which is adenosine diphosphate. Again, the cellular activity is going on, there's enough cellular signal going on, ATP again goes back to ATP again goes back to ATP, right?
So
And
I
again,
think, Sushant, for the benefit of our listeners, let's put it like that, let's say that ATP, ADP, and
AMP,
monophosphate,
AMP, yeah.
AMP, right?
Yeah,
There are three levers. So they are
yeah,
pulled accordingly in the body when there is a inflammation. So when there's an inflammation, the ATP it becomes ADP, right? Or
yeah.
AMP,
No, no,
right?
no. So how it happens is when you're using your energy, ATP gets
Right.
converted to ADP. Again, if
Okay.
everything is going on well, ADP again goes back to ATP, right?
Okay.
Which is again restoring your homeostasis, right? But there is a lot of inflammation going on, and ADP again comes down further to AMP,
Right.
right? Right. So this is one of the cycle mitochondria gives us a lot of energy, and
Yes.
another thing is mitochondrial biogenesis. So
Hmm.
mitochondrial organelle, which is again nation bacteria, right? It has a capability to recreate, reproduce itself, what we call as mitochondrial biogenesis. So when you talk of mitochondrial function, it is about mitochondrial biogenesis as well as ATP production, right? And
Hmm.
both are regulated by its master regulator PGC1 alpha gene, right? Again, so again, it tells mitochondria to give energy at the time of need, or it tells to it instructs to release more of or produce more of mitochondria, right? So again, it is PGC1 alpha is one of the said to be one of the key factors which can improve your mitochondrial biogenesis and can also impact your longevity. That's why there's a lot of supplements like NMN. There are a lot of other foods such as like polyphenols, a lot of herbs. Again, naturally nicotine found in various foods such as tomato, potato, right? Who could which could help in mitochondrial biogenesis and or folic acid, thyme and peppermint and a lot of these things. Even NMN, broccoli, avocado have NMN, right? So you don't need those supplements as such, right? So these are things which activates your PGC1 alpha and could lead to mitochondrial biogenesis, right? But if your mitochondria is performing very well, your metabolism is top class, probably overactivation of PGC1 alpha could lead to production of free radicals, which could lead to oxidative stress and mitochondrial dysfunction, right?
Right.
So again, it is not everything, having a more of mitochondria is not always good, right? I mean, again, here the role of nitric oxide comes into picture, right? So nitric oxide again is regulates and stimulates the mitochondrial biogenesis, right? So it is important. Nitric oxide is one of the key factors in your telomere length shortening, in your mitochondrial biogenesis, right? In halving of oxidative stress, reducing inflammation. Again, nitric oxide plays a very key role, right? And this has not been studied by any of the companies who are claiming that we are improving your biological health, we're giving you biological age, right? So DNA methylation is just one small aspect. You have to look at the overexpression and underexpression of all genes, including human genes, including oral microbial genes, oral gut microbial genes, right? Even mitochondrial
I
genes, right? So it's so all these are just you have to cover the entire story, entire biological storyline of an individual, right? That is very very important from this particular. Another thing is that you know when you're taking, and this is no brainer, when you're taking, so our cell membranes have fats like cholesterol, like fatty acids, like lipoproteins, and it is required to maintain the structure and fluidity of cells, right? So when we take a lot of seed oils or trans fat or processed oils, right, it changes your structure and fluidity of the cells, and cells become dysfunctional. So it can impact, it can lead to mitochondrial dysfunction, it could lead to aging, right? Similarly, when we are taking too much of drugs such as statin, right, which is probably, it is a wrong notion. I'm going to cover it separately,
Yeah.
but when you talk of cholesterol,
Hmm.
so a lot of doctors would focus on reducing cholesterol below 200. It's a crime, when you do that, you can't get vitamin D, you can't regulate your sex
And
hormone,
and
you can't.
and secondly, how your brain will actually work, because your
Yeah.
brain needs that cholesterol for functioning
In
properly.
fact, every cell of all cells of every tissue needs that, right? So as I
Yes.
mentioned, it changes the structure and fluidity. If you don't have cholesterol, you will have no nitric oxide, you will have type 2 diabetes, you will have cardiovascular disease, it will impact your aging and a lot of these things, right? So essentially, uh, you have to look at, entire holistic approach. When we talk of epigenetics, we talk of genes expression of everything going on inside your body. Just simple DNA methylation will not work, or just simple telomere length improved telomere length shortening will not work. Right? You have to look at your inflammatory markers from your oral microbiome, from your gut microbiome, the mitochondrial biogenesis, the production of nitric oxide, endothelial cell dysfunction, oxidative stress, uh, blood flow, oxygen delivery, again, all is linked to nitric oxide. So nitric oxide is something which is going to regulate a lot of these biological processes, right? So,
That's
so
correct.
that is something important. So from a biological age perspective, it is too early to to give you a biological age because you need a lot of data sets around oral microbiome, gut microbiome, human genes
And let's
expression.
let's be honest, do we have that much data?
Yeah,
Do we
and
have
and that
that
is
data?
that is the reason we have not we are still collecting data. We have not started giving biological age. It doesn't make sense, So
Yes, yes,
so we know that there are certain so we know that certain markers, inflammatory markers, or mitochondrial dysfunction or oxidative stress could impact your aging. But it's we need to collect a lot of data points around here, right? So
absolutely.
first is understand the cellular mechanism behind mitochondrial biogenesis, behind hydroxyl production, behind production of various pro-inflammatory markers or anti-inflammatory markers, right? What is the nutrient absorption, your response to various drugs such as statins, right? Your response to various, uh, you know, foods which knowingly and unknowingly have these palm oil, seed oil, corn seed oil, and a lot of these processed seeds oils which we do not realize, and these impact your cellular functions, right? So
Yes.
so so that is something which is has to be taken care of.
Mm. I think that's really important. And for an end user, Sushant, I mean, I think most of the people are curious to know that how do we decipher the longevity aspect? Like you said, there are so many ways there. I mean, DNA methylation is only one way, right? That's one of the ways.
One
Now,
of the very small ways.
yeah, one of the very small aspects, right? But what about a comprehensive thing? Who is doing that? Is there someone who is actually doing that? And if somebody is claiming to do that, is it actually, going to benefit them?
So India, I don't know anyone is doing it, looking at all the aspects, looking at your oral microbiome, looking at microbiome, looking at your natural cell production, looking at your mitochondrial functions.
It's not.
I don't think
I
that,
haven't,
uh, I
as
don't
per
think that anyone
my
is.
knowledge, no, I haven't
So
heard
from
any
from
for
from a
that.
longevity perspective, you should look at a couple of things. You should look at your network site production, right? Again, we could give you we do when we decode your oral microbiome, we give you network site production, right? You could also look at, your inflammatory biomarkers, metabolites released by gut microbiome, oral microbiome. Again, we can do that, right?
Yes.
Mitochondria we are not covering as of now, right? That's a next step. We are soon going to launch the mitochondrial.
Yeah, but that we will be launching, because we
Later,
need that much data, right, in order to do that. So of
yes,
course that is one of the key reasons. But
yeah.
I
So
think yes,
one,
this is something which is already being propagated surprisingly in the Indian market. In the US, I know that there are some companies, one or two there who are doing it. But in India, this is being propagated a lot in the name of longevity. They're selling almost each and everything, right? So I think you should, what we should be able to conclude this talk with good amount of tips to the users, so that they
yeah.
can actually they should not be able to fall prey to such things.
No, see, that is entirely their choice. How so
Yeah.
nowadays people are very smart. They understand what is truth, what is not. But from our perspective, it is only to educate, right? So DNA methylation is not a solution. Howard Clock in US have did that a lot of years back, but it is now clear that there's a lot of other inflammatory markers, right, which we should look at, right? Again, the oral microbiome, the gut microbiome, the mitochondrial, the nitric oxide. So if someone is not looking at nitric oxide production, either by endothelial cell functioning, or either by oral microbiome, then probably it's a cooked up story, right? In India, we need a lot of data which is not there when it comes to aging and longevity. We need a lot of data on mitochondrial gene expression, oral microbiome gene expression, cut macron gene expression, or nitric oxide production. You need a hell lot of data, which is not there. So it's too early to predict a biological age, or compare it with your chronological age, right? Yeah, but we could look at inflammatory markers. Few things, obviously, avoid the drugs like statins. Do not fall for things like you have to reduce your cholesterol, you have to optimize your cholesterol levels. High cholesterol doesn't mean the risk of heart disease, right? We avoid taking all this processed oil, which is going to change your cell membrane functions and structural impurity, which is going to cause cell dysfunction. Do not take mouthwashes, avoid fluoride in your toothpaste, right? Which is all those things which are going to shut down your natural production, right? So again, do not, we discussed this day before about L-arginine. Do not take L-arginine supplements. It is going to further impact on oocyte production because your body produces your L-arginine, semi-essential amino acid. Your body itself produces it. You don't need that, right? So these are the few things you should understand, right? And that's it for today. Yeah.
Thank you, Sushant. This was a very interesting discussion. And for all our listeners, please do share, listen to our talks, keep sharing it with your family and friends. And thank you. Have a
Thank you.
nice day.